Welcome on board, CoffeeJUG. Today I'm happy to introduce you our next speaker, Billy Korando. Billy Korando, Java developer advocate at Oracle. And he is going to talk about Java 17. So let's get started. In Community We Trust, it's our domain driver, and we already reached 27 unique events and more than 500 unique participants in our community. Also, let me introduce our organizers. It's Andriy, Uliana, and Igor. And our program commit members, Olesya and Alexei, people who care about the quality of presentation. Also, many thanks to our partners, Avenga, Sombra, and Grid Dynamics, and to our community partner, JetBrains. Fill the feedback form after our talk, and you will able to win 1 year free license for any JetBrains product absolutely for free. We will send feedback form day after this event. So let's get tuned. Also, we support Ukrainian charitable organization Tabletochki. We set the goal for our community to reach the 10,000 UAH to donate for this organization, and also you can join to this program by this QR code. And happy to say you that we already reach 9,000 UAH, so that's awesome. And also we have the activity bonus after talk. Feel free to ask the questions, and after talk the Billy will choose the best question, and this person will have some activity bonus from us. Also join to us in Facebook, Twitter, and Telegram. So see you and have a nice talk.
All right, everyone. Thank you for joining, or thank you for thanks for letting me join CoffeeJUG. An absolutely fantastic name, and thank you for that introduction, Lesky. Just to go ahead and just reintroduce myself real quick. My name is Billy Korando. I'm a Java developer advocate with Oracle, and we're going to be talking about Java 17 and beyond. Of course, Java 17 here was just released 2 weeks ago on September 14th, so it's obviously kind of a big deal now in the Java world. So just a few notes I want to quickly go through. I'm a very demanding speaker. If you have any questions at any point during this presentation, definitely please reach out and ask. I think this is being live streamed to YouTube. I know there's going to be a bit of delay, so between you asking a question and them getting relayed to me, maybe a minute or so or two, but definitely ask them. The whole point of my being here is to get you informed about Java and Java 17. So definitely ask questions to make sure that I'm answering anything that you have interested in. Follow me on Twitter at Billy Korando, or also you can email me at billy.korando@oracle.com. So if you have any questions, anything to cover during this presentation, want to get some more detail, whatever it might be, definitely feel free to reach out to me at either option, and I'll be more than happy to answer any questions. We'll see. We'll have a little bit of time for some live code examples at the end. I've kind of changed this presentation a few times in the time to where maybe not as quite as necessary, but we can maybe go into that towards the end. Of course, the big link to know about here is the link to the slide deck, which is on my GitHub at wkorando, and just to Java 17 and beyond. You can get all these slides, and I'll make sure to kind of get them updated and here shortly after this presentation to make sure you had the most up-to-date slides that I'll be actually having during this presentation. All right, our agenda. There's going to be 4 major areas. The new language features have been kind of added since between Java 11 and Java 17. New runtime features, things that are being deprecated, removed, and there's some other key changes to know about. And then the future of Java, what's going to be kind of coming in these upcoming releases. If you have an intense desire to know more about this presentation or about some of the content within this presentation, I've been doing a weekly segment called Sip of Java for about 4 or 5 months now. And so a lot of what I cover in this presentation will actually also be covered there in more detail, so you can check that out as well. With that said, let's get into the meat of this presentation. Let's start looking at these new language features. So the first one we're going to look at is text blocks. This was added in Java 15, and the JEP associated with it is 378. If you're not familiar with what that means, that is Jdk Enhancement Proposal. And whenever there's like a somewhat significant change added to the JDK, it goes through this JEP process. And so why that is relevant is you can see all the JEPs that have been proposed or been added to Java in recent releases, or in some cases they have been withdrawn later. But this page here, it can show you, or it gives great detail, and this is the one for text blocks, on here, like the motivation for why it's being added, a description of the change, and just a bunch of relevant and useful information on this change and how to use it. Going to be more detailed I can have time to get into for each of these changes during this presentation, but this is a really excellent source of information about the changes that I'm going to be covering. So definitely check these out if there's a particular change that you're really interested in and want to know more about it. But let's go ahead and take a look at text blocks. So at some point, all of us as Java developers have had to work with some sort of formatted or markup language within our code. Here in this example, I have a very simple JSON message of kind of like my social media profile or whatever. Of course, you know, whether it's JSON, XML, HTML, or something else, we've all had to kind of do this at some point, and it's terrible. It's a terrible experience because there's so much of this, you know, like new line, tab, we have to escape out quote and all that. And so even though we can kind of read here, we're familiar with it, what's going on here, once we add much more complexity to this message, it's just going to become extremely hard to really even understand it, let alone maintain it. So we've added text blocks, and text blocks are denoted by triple quotes at the start, and then you return one line, and then triple quotes at the end of it. And then within this area, format or the need for escaping and all of that is significantly reduced. So here, we don't need to do like the \n for the new line character. We don't need to escape out the quotes for within here, and we don't need to add tabs because all this white space and all this formatting is preserved within the text block. There is a bit when it comes to incidental white space. So like all this white space right here is going to be ignored. There's some specific rules around this that I don't want to go into too much in here, but pretty much as long as you kind of line up the enclosing triple quotes with what white space you want to ignore, that really will work for you most of the time. Like I said, there's a few things where if you put like the triple quotes here, then all this white space would be preserved. If we moved it to the right further, then it would still actually ignore this white space. But really, as you kind of follow this, like keep the triple quotes aligned with like the farthest to the left of what you want to have white space reserved will be the kind of best way of handling that. So then a bit more. So of course there's like string formatting. And so if we wanted to put in parameters here for, you know, being able to fill in values for first name, last name, and Twitter handle and job title, that will work just as it does with a normal string. I mean, in fact, you know, all this behind the scenes is just still a normal string within Java. But yeah, that will work just as well as it did with a normal string. If you were to work with like a like a really long single line character or single line, like in this example, like we want this all printed as a single line, either by system out print line or whatever's rendering it. By putting a backslash here at the end of the line, that ignores the carriage return. And so when this was to be printed out by system out print line here, this would just all be printed out as one single long line. The next feature I want to talk about is switch expressions. This was added in Java 14, and then the JEP for this one is 361. So switch expressions. So we've all used switch cases at some point, and they are still around. You can still use them. We're not being forced to move to this, but switch cases have been added. They've extended switches, and so the syntax of a switch case statement has a colon, but a switch expression has this arrow syntax to it. And so what switch expressions do is when this case is matched, then only the code to the right of this arrow is executed. There is no fall through like there is in a switch case statement, which is often a frequent source of bugs, and then also it just would really kind of make the code harder to understand because you would often then end up having to write a bunch of different or having to write a lot of break statements in there, which just starts to become quite messy when you're looking at it in the code. If you have a bunch of cases like this where each one should only be executed for just that specific case, then you have a bunch of extra break statements. It's just makes it really hard to read. Switch expressions can also return value from them. And so like here in this case, we're returning a string. So like all these have to match the type of the return value or have to be at the same type or child type of it. Now, if you can also execute a code block. And if you were to execute a code block and you're returning value from it, you would have to use the reserved word yield to then return the value you want to have returned out of here. So like in this default case, we have invalid that's going to be returned out of it. Now, yield is not a keyword. It's just a reserved identifier, kind of like var is. So you can still technically have a variable named yield within your code. That won't cause any sort. It's only within a switch case where yield be valid. So as you probably may have noticed, in all these previous examples, we've had a default case. And that's because switch expression has to be exhaustive. You can't just have a few examples and go through it. It has to cover every possible example. And most of the time, as of right now, that means you're going to have a default case. Now, if you had like an enum here and you're covering all the different constants of the enum, you can actually not need a default case because, well, now you exhaust it. If you're switching across this enum, well, we covered all Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday within this, so a default case isn't needed. One other small thing that I don't have in here is that also yield can also work with the old switch with this colon syntax. So I could do case colon and then yield Sunday out of this, and that would also work as well. The next is we're going to look at our first example of pattern matching that is going to be added to in Java when I touch on it beyond. But this is like a really big change that's going to be coming in several different JEPs over the next few years that's coming to Java. That's going to be a real gain for Java developers, making Java easier to work with, kind of reducing a lot of the boilerplate, which can, make code easier to read, and then also hopefully less error prone. But yes, pattern matching for instance of was added in Java 16, and its JEP is 394. So again, something we're all familiar with as Java developers is we have some sort of variable that we just don't know the type of. So like in the most common cases, like we're getting it from some sort of external remote system. It's coming in and it's just some very generic type. It could just be like a very generic string, or in this case, I have object. And then we have to do like, oh, okay, is this object an instance of whatever type we're looking for? And then when that's true, within that if block, then we assign that value to whatever variable we want it to be. We cast it, and then we do our work with it. This isn't too bad, but there's a few opportunities for bugs to crop up here and there, and it's just for more verbose than it needs to be. So now instance of has been extended to where it can take a pattern variable. So when this is actually evaluated true, this instance of if actually is a string evaluates to a string, then now a string is assigned to the value of actually a string. And then we can then reference that variable within the if block. So now a string, it is what's called, it's flow scoped. And so what that means is that now a string is in scope wherever this is definitely absolutely true within the compiler. So again, most of the time what that's going to mean, it's going to be available within the following if statement or if block of where this evaluation is happening. But just to understand kind of exactly the ramifications for that. So like here, if actually a string, now I'm a string, they said it'll be available within this if block, but outside of it, it wouldn't be available. This would give a compile error because now a string is out of scope. Kind of similar, let's say if we took out the if block and we just had the evaluation here, like we're doing like a Boolean as a string, actually I'm a string, then assign it, it would again still be out of scope once it actually leaves this evaluation area. Of course, and it's also, so like here, if we did like an R after this, of course, this would have to evaluate to false for this to be checked. So then again here, now a string would not be in the scope. But it would be, of course, in scope with and, because, of course, this would have to be true before this would be evaluated. So this would work. Of course, you could get weird with this. Not that I would recommend doing any of this. In fact, I would highly recommend against not doing it. But like if we put like a not around this, then now a string would actually be in scope within the else block, but not the if. If I was to do this, like if this is not valid, then throw an exception, then of course actually this now string would be available out here. But 99% of the time, what we're going to want to do is something like this, where you assign the value to the variable at whatever proper scope it needs to be. Or if you need to assign it, this is what you would do. That's what that would look like. So sealed classes, this was added in Java 17, and its JEP is 409. So what sealed classes do is allow you to get control over what kind of classes it allows a class to be widely accessible, but limited in who can extend it. So like, let's say within your organization, you have like a concept of user. And there's really only going to be three major types of users within your organization. You would have like a customer, you could have your walk-up guest, and then you could have like some sort of admin. So then what's also nice about user is it controls like the direct classes that what classes can directly extend upon it, but the subclasses, they're allowed to evolve at their own whatever behavior as it might need to be. So for example here, when you extend off of it, all these classes need then to declare as either sealed, non-sealed, or final. So in this case, this hard line around it means this guest is final, so nothing else can extend upon it. Customer is non-sealed, so anything can extend across off of customer, just like it could any normal class. And then finally, admin, it's also sealed, and then it can allow two classes to extend off of it. So here, what this kind of looks like in code is we have user, and it's sealed, and then it says it has a permits list that can be admin, customer, and guest, just kind of like we showed here in this little chart. And then like here, sealed is also applied to admin. And I should have updated this example. So if you were to the permits clause is optional. What you could also do is if you define the subclasses for a sealed class within the same source file, you don't need to do the permits clause. So if I put super admin and normal admin within this same source file as admin, it could be inner child or it could be at the same level as an auxiliary class. I won't need to put the permits clause. The compiler will just assume that these classes defined within the admin sealed class are the child classes of it. You know, of course, assuming they extend across admin as well. But yeah, so the child class of a sealed class needed to define as either sealed, like I did with admin, or final, like here with guest, or non-sealed, like with customer. Which again, that means anything can extend off of customer. But again, what this allows is for a classes to be widely accessible but limit extendability. It can also be good for providing domain information, just because like within organizations, there's going to be this like certain kinds of concepts that there's going to be a limited number off of them. Like it could be like account type could be, you know, account type for business customers and just personal customers. Like, you know, that could be the two different account types you have, or just so many different things, you know, within if you have you have like boats, you know, maybe you have like different types of boats based upon the types of boats that you're like servicing. You would have maybe different classes for each of those, but there wouldn't be anything beyond those kinds of types. So that could be a good way of communicating domain information. And then actually in future releases of Java, this concept is going to be built upon to where you can actually have like a switch I showed earlier, where you could actually go through and not have to have a default case because it could switch across like the different user types, which could be very helpful. So the last language change I want to cover is with records. And this was added in Java 16. And again, the JEP for this is 395. Records is probably going to be one of the biggest changes to Java, particularly between with it and then some of the future changes that are going to be building upon records since lambdas. And I don't say that lightly because lambdas have been pretty significant, and also strings have been pretty significant changes to Java as well. So probably the first and most immediate benefit of records is that it reduces boilerplate. So like here, we have like a method here that is like processing user types, and we maybe just need to have like a small person type that's just kind of like a throwaway class just to kind of encapsulate something. And if we wanted to define that within the method, I mean, it quickly becomes dozens of lines of code, and this becomes extremely hard to read. But with records, well, that can all be defined within a single line of code. So yeah, you know, like this first name, last name, title, Twitter handle, all that's defined within here. And then the compiler will automatically generate a canonical constructor, so a constructor that matches all these four fields within it. Hash code equals toString, and then accessors for all these components. So when you define a record, these are referred to as components. So all these components of the record will also then, if I want to say person.first name, to get the first name of that record or that field. So the purpose of records are to be a transparent modeling of data as data. And so with that, there's certain kind of constraints also with it. One of them is a superclass is always going to be Java lang.record. Records can't be extended. They can't be abstract. And so with that, they're implicitly final. So they're always going to be the superclass's record, and you can't extend a record either. All the record fields are final. And so with that, they're sillowly immutable. So if in here, one of these components that I find was a list, I could add or remove from that list, but I couldn't change out the reference to that list. So again, it's sillowly immutable. It's not going to enforce that the values of the components can't change, but it's going to make sure that the reference of them doesn't change because, well, they're final. You can't declare instance fields. So that way, again, it's about being that transparent data carrier. If you could declare an instance field, then you can't just surmise the state of the record from either its constructor or its accessors. As I mentioned, accessors, hash code, toString, and equals are all automatically generated. But if you wanted to, you can override the default implementation or add your, of course, your own method definitions as well, because again, records still are just normal classes. So what that kind of looks like, you know, here I just added my own custom toString, and you know, I just wanted to maybe print out more in a pretty way than what is available with the normal toString generated method. Also, like, you know, I can just add my own toJSON method as well, of course, that, you know, for converting this record directly into JSON. So yeah, that's just like a couple examples there. A big change, and I need to update this presentation for it also, or a big improvement is one really messy area within Java is serialization. There's just like a lot of messiness with it just because of the way it was initially implemented. That kind of opens up a lot of security vulnerabilities. So, like, I could, if I had like a normal class, I could define like a runnable within it, and then I could define there's like several quote unquote magic methods within serialization, one of them called read object, and I could define a class that has a read object within it, and I can tell it to like run some extra code on your system where when I pass it through serialization, and it just creates a potentially huge security vulnerability. But records, again, going back to the fact that they're transparent carriers of data as data, they can be entirely reconstituted from their constructor or from they can be rebuilt through the constructors and deconstructed through their accessors. So a lot of those magic methods that govern serialization of read object, write object, and the few others, like their names are escaping me, they aren't used when serializing and deserializing a record. So that can close really many of the remaining security vulnerabilities with serialization. So all this is to say is if you're doing some sort of remote communication with at all, but particularly with a service that you don't have control over, I would highly recommend looking at converting all those all those objects that you're serializing and deserializing between those services to records to potentially close a lot of your vulnerabilities. Like, definitely look up and read about some of the potential security issues with serialization if you want to have your hair stand on end from fear of what could happen, and then consider switching to records. All right. So with the new language features covered, let's start getting into some of the new runtime features and improvements. CDS updates, this is class data sharing updates. They've been made to be a lot easier to work with. So quite a while back in Java 5, if I remember correctly, class data sharing is added. And so what this does is that whenever a JVM process starts up, it's going to load certain core classes from the file system into memory to then run your application. And of course, this is going to be the exact same behavior for every JVM process that happens all the time. So because this is the exact same behavior, well, that obviously is an opportunity for optimization. So CDS was added that added like a pre-processed file of like all the classes that were needed that can then be memory mapped. And this can then be shared across JVM processes, which can save both a little bit of startup and also memory. In Java 10, app CDS was added that then extends this behavior into the applications themselves. In Java 12 and 13, this process was made easier. So with default CDS archive, kind of what I was talking about before with Java 5, like you would actually have to manually set up this archive. But now with the core Java classes, a default archive is already shipped with all binaries, so you don't have to do that. And the dynamic CDS archive makes it much easier to work with app CDS, so that way you would do a archive classes and exit. So you would start up your applications, and then the JVM will make a note of all the classes that are being loaded, and then create this dynamic archive out of it. Then when you run the application again, instead of trying to load all those classes from the file system, it will load it from this archive, which actually would have a pretty significant benefit. Okay, I forgot to include the timings on it, but in like a test I did with a simple Spring Boot application, I believe like it went from about like 8-second startup to like a 6 or 7-second startup. So like a maybe about 15 or so % increase in startup speed. It's going to, of course, vary a lot by your application, but it could have a somewhat non-trivial improvement in startup time. And if you have a lot of those same processes running on the same host, as I mentioned, that's memory mapped. So every other JVM process will use the same memory location instead of copying itself, which could also save some memory. But that will only be if you're running the same if you're all running those JVM processes on the same host. Like if you had it in 2 different Docker containers, I don't think you would actually see any savings in memory there. The next is ZGC. Z doesn't stand for everything. That's just a designator that gives you this new garbage collector. But it became a full production feature with Jdk 15, Jeff 377, and it's a complete redesign of garbage collection within Java. Currently, if you're familiar with garbage collectors, this is somewhat significant. It's currently only a single generation, though they are the garbage collection teams are looking at making it a multi-generation garbage collector like we have right now with like Parallel or the G1 garbage collector. But the goals behind ZGC is to have a super low latency of under 10 millisecond pause times, which is very, very fast. Extremely scalable. So if you're working with multiple terabyte heaps, then it can work with that. So if you do want to use that, if you think you have use cases within your organization where you're using extremely large heaps, and you also really need minimal pause times, definitely give that a check out. You can just say with the JVM arg, use GGC, set the heap size, and then turn on debug logging for your GC just so you can actually see how it's actually behaving to see if that can actually work better for your organization. All right, this is definitely one feature every Java developer is going to absolutely love, helpful non-pointer exceptions. Again, this is something that if you've only been a Java developer for even 6 months, you've run into a null pointer exception on a line where there could be 2 or 3 different values or more that could be null, and you just have no idea what it is. So then you have to throw some sort of debug statement before that says like, trying to print out the value of all the different possibilities that could be null. So then you can then actually go in and put in your fix to prevent the null from happening, which again, extremely annoying. But now, instead of before Java 14, where you would get this, again, the very generic null happen on line 7, now it will actually say what value was null, and where the null actually happened, of course, still on the line. But now that just dramatically makes it easier for tracking down nulls. AMD Architecture 64 support has been added now to all the major operating system distros. So Linux, that was added all the way back in JDK 9, Windows, JDK 16, and now Mac OS with JDK 17 all support AMD Architecture 64. So hopefully your Mac OS, if you're running on those really cool new Mac M1 laptops, it should work much faster now with JDK 17 because you're getting native support instead of having to go through the, I think it's Rosetta translation layer. With every new version of Java, there's always improvements being made to the JVM. I need to rerun an example with Java 17, but again, Spring Boot, Pet Clinic, it's a POC application that the Spring team put together to demonstrate Spring Boot. And this just gives you the versions I'm using. I'm just sending just like a simple 500 request through it, sending a very minimal heap size and a garbage collector G1. We see a very noticeable improvement when it comes to application startup, and then the execution time is a bit faster. But one big difference is that when it comes to like having larger available memory spaces or larger available heap spaces, the JVM has gotten much better about how much heap space it tries to claim instead of trying to claim it all like it did with like Java 8. Like if Java 8, you gave it a gigabyte of heap space, or there's a gigabyte available and you didn't send a max to it, like it would go out and just grab it all. Java 16, 17, and so on, they are much more conservative with what they're claiming as heap space. So that way you're much more better with memory usage as well. The second to last part, we're going to be looking at some deprecation removals and then some other changes to know about. So the first two deprecations, so for removal is Security Manager, which is Java 4.11, and then the applet API. So the applet API back in Java 9, it was marked as deprecated, but now here with Jdk 17, it's marked as deprecated for removal. I'm not sure on what exactly version it will actually be removed, but it has now been put on notice that it's going to be removed. For the Security Manager, I think it's maybe just deprecated. Maybe it's not for removal yet. But pretty much here, you might hear that like, oh, we're removing the Security Manager, and now Java is going to be less secure. But the Security Manager is something that has not really frequently been used. And that's just because it's very complex to work with. And ultimately, a lot of what the Security Manager could do is much more easily administered at the operating system level. So ultimately, it's going to get removed just because it wasn't seeing high usage, and it's been ultimately superseded by other better operating system level controls on how to properly secure a Java application. Some things that actually have been removed between Java 11 and now Java 17 is the Nashorn JavaScript engine that was removed in Java 15, and the CMS, or the Clear Mark Sweep garbage collector, which is removed in Java 14. The G1 garbage collector was made the default garbage collector starting in Java 9, and its behavior ultimately kind of replaced what the CMS garbage collector does. So if you were using the CMS garbage collector, you should be able to move to the G1 garbage collector and get improved and just overall improved performance compared to this one, the CMS garbage collector. So the others to particularly know about is starting with Java 9 with the introduction of the Java module system. One of the things was to more strongly encapsulate some JDK internals to allow them to evolve better, because we're no longer having to support public elements that were never meant to be public. The most prominent example of this, of course, is sun, misc, and safe. But what happened is in Java 16, illegal access was no longer the default argument. So you would actually have to explicitly turn on illegal access permit to get reflective access into some of these restricted modules. Now with Java 17, illegal access permit no longer works. So now you would actually have to explicitly add open to get reflective access to a module that might need it. However, here's a list of the APIs to which you don't need to do the add opens to work with. So sun, misc, and safe, the sun, reflect, reflection, and a few others of these as well. So if some library you're working with needs to have reflective access into these, you don't need to do adds opens to it. But as I mentioned, or I should also say, is that eventually, right now, if you were to add illegal access permit to a Java 17, it would just be a no-op. I think you may get a warning, but otherwise nothing would happen. Eventually, this JVM arg will eventually get totally removed to where if you try to put this in, you would actually get a runtime error. Then if for some reason some library that you're using is still needing reflective access to certain modules that it doesn't have access to by default, you will need to use the add opens either at the command line or in the add opens to the jar manifest. So So for some reason, some libraries, again, still need some reflective access to stuff. You can still get it, but you will need to actually now be much more specific in adding that. So in the first section, I'm going to talk about all the language features. Like that's like some of the new major language features that were added. But a whole lot of new classes, methods, and fields have also been added that can make Java easier to work with. And to check that out, actually, the Java doc tool has been updated to where it will show a new section to it. Jdk, perfect. So yeah, the Java doc tool has been updated to where a new section will be added, and you can see all the new classes, all the new modules, packages, interfaces, classes, enum, and so on that have been added. You can even break it down by the various versions as well. And this can be really helpful to see some of the new stuff that's been added. Certainly one thing that has been updated quite a bit over the past few releases is, is Java utils. There you go. So Java length string is probably one of the classes that most Java developers, we're all very familiar with it, that has actually seen a lot of new changes added to it over the past several releases that have made it a lot easier to work with and cover a lot more common issues that Java developers often have with strings. So definitely check this out. There's a good chance there's been a bunch of other changes made across all across Java that just have made many classes easier to work with. So the last thing I want to cover is the immediate future of Java, not necessarily the deep future of years from now, but what's going to be kind of coming up in the next several releases. So something I touched on a little bit earlier is how pattern matching is starting to really come into Java, and that is our project Amber. And so we saw the first explicit example of that with a pattern matching, for instance, of. Also in Java 17, this is a preview feature, but they also have pattern matching for switch. So you could actually have, like you could switch across class types. And this can be very helpful when you have sealed classes. So like the earlier example I used of like a user sealed class is if I was to have like guest, admin, and customer all within my switch case, my switch expression here, I wouldn't need to have a default case because the compiler would know that I am covering all the different possible immediate subtypes of user. So we're going to be seeing more and more of that added of these new features like records, sealed classes, and so on that are being added to with pattern matching to make them even easier and more powerful to work with. Another example of pattern matching being added is for both records and arrays, where instead of having here, like we check to see if this is like an array string, and then we explicitly call the different elements to that array string, we can just simply directly reference, like saying string S1, okay, that refers to the first element within the string array, and then string S2 refers to the second element because, that's defined first, that's defined second. S1, S2, it doesn't have any special meaning. And then that can then just be referenced here then within like the if block. But that will make it much easier to work with arrays than what it currently is, where it becomes very verbose to reference a specific element within that array. Also, somewhat similar with records, it's going to be much easier to construct and deconstruct, particularly deconstructing a record, getting the elements out of it. It'll be much easier to pull that information out as well. But yeah, you can read more about it here. So Brian Getz, the language architect for Java, I think this was, well, I guess we can see. So yeah, 2018, he lays out the motivation for pattern matching for Java. And so, of course, this is now almost 3 years ago. But if you actually start reading through this, you will see how actually a lot of what he talks about in here has been added. And then from that, you can also then surmise some of the things that haven't been added. What's the goal with all this pattern matching in Project Amber, where's it's heading? You can really kind of get a great understanding of that here, to where Java is heading. And again, this is the immediate future. In the upcoming releases, a lot more of this stuff will be added to the Java language, which will just, again, make it much easier to work with and much more pleasant to work with. You can check out the early access builds. So Java 18 is already available in early access, and actually Java 19 here should probably be available here pretty soon as well. But yeah, you can go and download it here. So if there are certain things in Java 18 you want to check out, you can go ahead and check that out now. The 3 other major projects that are going to be having some deliverables either have already been delivered or going to be coming here really soon are Project Loom, Panama, and Valhalla. So Project Loom is going to be introducing virtual threads, which is going to be a significant improvement when it comes to parallel processing for Java. So you can check it out here. And it looks like it's starting to get pretty close to where we might start seeing some deliverables from Loom in the upcoming Java releases. So definitely is worth checking out. Panama is improving the native interfaces for Java. So if your organization is doing something where it needs to have native access to certain libraries, checking out Panama can be very useful. And then lastly, Valhalla is improving the values, how Java works with values, and you should definitely check that out as well. So some code examples, like I said, the link to this slide deck. Sorry, my mouse is very finicky. It likes to always go back to a previous slide at times. You can check out here the link to this slide deck at my GitHub. There's just a link to the JEPs page that I showed earlier. Also, always check out the release notes for every release. They all follow the same pattern. So if you want to go back to Java 16 release, just replace this with 16, 15, 14, 13, and so on. Check out the release notes. It shows you all of the things that's changed. And then also can link you to things like the Java language specification and all that. So you can really get an idea of all the stuff that's changed and how to use a lot of these new features or how to migrate as well if needed. Also examples of with my SIP of Java is also here as well. So you can definitely check that out. And then I know there is a lot of concerns when it comes to upgrading to the newest versions of Java. This is a really great article from an engineer at Netflix, where at the time when he started, they were all on Java 8. And he was wondering about, can we not move beyond Java 8? And there was a lot of concern that, we can't because of, various reasons. And the big thing to take away is that really a lot of what it comes down to is just upgrading your dependencies to be on either the latest version or at least a relatively new version. I would generally always recommend to be on the latest versions for your dependencies for security reasons, but all the same, just really by upgrading his dependencies and the projects that he was responsible for, he was actually able to move them to Java 11. And that should be pretty similar also here for Java 17, where if you just get to the most recent dependency or most recent versions of your dependencies, you should be able to upgrade with relative ease. Because a big thing with Java is backwards compatibility. I did mention we had a couple removals and deprecations, but generally those aren't going to happen unless that code is just really not being used by anyone. So for most people, for most developers, being able to upgrade should hopefully be, relatively painless, or at least not too painful. We're going to make a lot of changes to your applications. So thank you so much for coming to this presentation, and I'll be more than happy to answer any questions you might have.
Stop. Hello everyone, thank you Billy so much for this talk. Billy, there is some couple of questions from our chat. Let me read the first one from Oleg Mining. Hey, what about Java 17 performance in comparison with the previous ones?
So yeah, I forgot to run a performance test. It's one of those like it's on my to-do list, and I just somebody keeps trumping it with it. But let me go ahead and go back to that. But yeah, there is pretty significant performance enhancements between like Java 17 and even Java 11 or Java 8. Let me. There we go. So yeah. I guess one thing I didn't also touch upon is like this performance enhancements. This performance enhancements that you see here, this improved startup time, this improved performance. I'm using the exact same binary here. So I compiled this the Spring Boot application with Java 8, and then ran it on Java 8, and this is kind of what I got back. And the exact same binary, not recompiling or anything like that. You should see a pretty noticeable performance enhancement. Of course, it's all going to vary depending upon your application, what it's actually doing, but you should notice a non-trivial performance enhancement.
Thank you, Billy, for answer. And the next question, pretty interesting, from the Metro Novohadsky. There are a lot of improvements covered in JAPs, but still upgrading to Java 17 will require efforts. Business, how to sell it?
So a big one, it would be here with like general performance improvements. Like I said, it's a non-trivial improvement that, without necessarily having to, completely rewrite your applications, again, even using the exact same binary, you should be able to see a pretty significant performance improvement. There could always also be security improvements. So like when we're removing something from it, like say like if there was some sort of security issue with NAStorm that we just never knew about or whatever, the fact that it's no longer in JDK 17 would mean that any sort of security issues within it would no longer be an issue that could affect your organization. So in that way, you would also have, that would be better off, is that you would be a bit more secure by running on JDK 17 than even a fully patched JDK 11 version. Some other improvements, we can also see like some of these other the helpful null pointer errors. Again, that's something that plagues all Java developers. Being able to more accurately find out what's going wrong in your application can then make it that much quicker for your organization to respond to issues. And for that matter, also a lot of the command line tools, and there's a lot more things like I didn't even touch upon with like Jdk Flight Recorder, which is a great tool for getting diagnostic information out of your Java application. Jdk Flight Recorder, I think, was added in Java 5 or Java 6. Either way, it's been around for a while, but it continues to see more and more improvements with newer releases of Java that can give you better information out of there, smaller performance impact, so you can be more comfortable about running in production as well. So those are also some benefits. And of course, obviously, the fact Java developers can be a bit more productive by taking advantage of some of the new language features or being able to write more clearer code would also be some benefits to your organization as well. But yeah, performance improvements, security, and better diagnostic capabilities would all be major benefits to upgrading to the most recent version of Java.
Thank you, Billy. And the next and last question from Andrew. What about a memory footprint for classic formatted text? Use text block.
So like what's the memory footprint of text block compared to like a normal string? I guess I haven't actually specifically checked that, but I don't think there should be any difference when it comes to memory, because really what I'm quite certain happens under the covers with the compiler is it sees a text block and then converts it to just what would a normal string equivalent would look like within your code, within the bytecode. So there really shouldn't be any difference in performance or memory footprint between a text block string and a quote unquote normal string, because I think really all within the compiler, it all looks the same. I guess I'm not 100% certain, but I'm about like 99, 95, 90% certain that you shouldn't see any measurable difference between a text block and its equivalent for a normal string.
Thank you, Billy.
Thank you, Billy. I guess one last thing. Sorry, I forgot to mention someone, but there is also the JDEPs. So there's the JDEPs command line tool. Hopefully I can find that. But what the JDEPs tool is, you can use JDEPs and then whatever Java deployable the class are most likely, like the war or jar or whatever it might be. You can have it analyze that file to see all the dependencies within the core Java that it has, and that can also kind of help you with understanding areas you may run into issues when trying to upgrade it. So definitely check out the JDEPs command line tool, and you can use that and run that to analyze your applications to see any sort of areas where there might be some sticky points when trying to upgrade it as well. Sorry, yeah.
And also we have one more question from
Okay, great.
Maybe you have or know about some performance tests from real projects, especially big data projects, test stories.
I got you. I wish I did. Actually, that I'll have to make a note of that, because that would be really good, because there's definitely a huge difference between doing some real simple example like I did with Spring Boot that wasn't really connecting to any external services and is a really simple project, compared to like the real big projects that we actually work with at our organizations. I don't have anything offhand, but I'll try to make a note of it. And if I do find anything that's really good, I'll be sure to tweet that out as well, to see some of that comparison between, like Java 8 or Java 11, and then of course Java 17. Great question.
Okay,
great.
No another questions. So thank you guys. We will switch on technical pause and then come back. So again, thank you, Billy, for this presentation. Also, many thanks to our partners, Awenga, Sombra, and Grid Dynamics, and to our community partner, JetBrains. Remember, fill the form, and after that, you will be able to win 1-year license from JetBrains for free. We will send you the feedback form right day after this event. Yeah. Also, feel free to donate to Tabletочки, Ukrainian charitable foundation. And we already reached 19% of the total amount. Yeah. And also, right now, Billy, you are able to choose the... And right now, Billy, you are able to choose the best questions.
Yes, all great questions. I guess if I had to go the best, I think the second one was good because I think it kind of gets to what me developers, Java developers, going to be need to make a case for the organizations why to upgrade. So yeah, question number 2.
Yeah. Okay. So Dmytro, feel free. We will contact with you, and you will be able to get the activity bonus from us. So. Thank you guys. Remember to join us in Facebook, Twitter, and Telegram. Have a nice night and bye.
Thank you.